Steady, ready, go? Huh? Steady, ready, go?
Yeah. 6 more minutes.
I thought that you are checking the heartbeat.
Ah, no. But I can do that too.
90, okay. You're a little bit nervous.
A little bit nervous, maybe.
Are you feeling better today?
Yeah. I wasn't coughing as much. So it's good.
Whenever I have some problems with throat, when I'm flying in the airplane, the air is so dry.
Yeah,
It's
very
hard to survive.
Yeah, it's bad. Like, that's why. Maybe that's why I got sick. Hello. Good. There are more seats in front if you want to have a seat. If you want to. It's great. It's really awesome. I'm gonna.
Raz, nie, poczekaj. Raz, raz.
Good?
Tak jest dobrze?
Is it
Tak,
on?
nie, tak.
Właśnie, no dobra.
Because second speaker wants talk to stick, maybe you want to?
Okay.
Okay?
Yeah, I don't mind.
Okay, it's better for us because we need to change power on, power off, so... Okay, we check. Włączyłeś? Raz, dwa, trzy, cztery.
Pomysły z tym? Okej.
Raz. Nic nie słychać. Raz, dwa, trzy, cztery. Raz, dwa, trzy, cztery. Raz, dwa, trzy, cztery. Raz, dwa, trzy, cztery, cztery. Raz, dwa, trzy, trzy, cztery. Raz, dwa, trzy, cztery.
Mogę jeszcze na manualu powiedzieć.
No to pilnuj tego na razie, no bo tak musi być.
Hello.
Działa? Not yet.
Okay.
We're testing something.
Ten ma inną charakterystykę, jako że więcej zbiera szumu.
Aha.
Więc jak płonią cisną, to będzie lepiej. No to
Możemy zaczynać?
dla mnie cały czas.
Okay, so we're ready. You can start if you want.
Okay. Yeah, I think it's time to start. Good. Hello. It's on, right? Okay. Okie dokie. Hi. Hello. Test. Okay. Can you hear me? Can you hear me now? Hello. Let-
It's for streaming only. So people will hear you in the streaming, but here you know, use
I
your
have
own
to
voice.
speak up.
Yeah.
Okay, okay. So this microphone is for streaming only, and you have to be quiet in order to hear me. Sorry. But anyway, welcome to the first Apache Airflow meetup in Warsaw. I'm really happy to see this enthusiastic crowd here. And thank you. And my name is Ayjamal. I'm your host today, and I'm also one of the Apache committers, Apache Airflow committers here today. And yeah, and I come from Seattle. I'm part of Google Open Source Program Office. That's why we do these meetups. And we prepared really cool content for you today, no matter how familiar you are with Apache Airflow. So we have Victoria Nemkin, who will introduce you to the like beginner's guide in Apache Airflow, and we'll also have Lee Cole talking about best practices of using Airflow and also offering managed service like Google Cloud Composer. And we have Tomasz Urbaszek. I hope I'm not messing up your name too much. And yeah, he will also talk about operators they generate for the Google services. And finally, there's going to be use case from Allegro, Bartolomei. Okay, I'm gonna skip your last name, I'm sorry. But there are a few things that I want you to know before we start. After each session, we're gonna have Q&A sessions around 5 minutes. Please feel free to ask any question from the speakers. And if you weren't able to ask, we're gonna have networking time after. So please hang around and connect with the speakers and others. And we also prepared a survey for you. Please fill it up afterwards. And we're not going to collect any personal data. It's mostly about the content that we present here and also about your experience using Airflow, and that survey answers will help us improve to host similar events in the future. And related to that, I have more announcements. We're gonna host Apache Beam Meetup exactly in the same place on November 14. If you don't know, if you haven't heard about Apache Beam, it's really, really cool open source project that was started at Google, later donated to Apache Software Foundation. And yeah, it's for batch and streaming data processing. It's cool. So if you're interested in that, I know it's a hot topic these days, please check out the website, also RSVP here. It's called Warsaw Apache Beam Meetup. Very descriptive. Also, Jarek and Tomek, they're going to host Apache Airflow contributor workshop in Berlin as part of ApacheCon. So if any of you going to Berlin these days, like October 24th, please make sure to drop by. And you can also RSVP here. And during this event, I want to remind you that we have code of conduct. Please be really, really nice to each other. And if you're feeling unsafe or uncomfortable, please reach out to the organizers. I'm here, and there are a bunch of folks from Polydea that can assist you. Also, restrooms. Restrooms are on that directions. You just follow the sign, and there's the card hanging on the right of the door, and you just tap and get in. And also there's Wi-Fi, public Wi-Fi that you can use, and the password is simple as Polydea. And also, this event is possible thanks to our sponsors, thanks Google Cloud for all the food and all the swag, and yeah, and Polydea, thanks for hosting us here and taking care of all the organizational stuff. So enjoy this event. I hope you like it, and please come to future events. Cool. Thank you.
Hi, I'm Justyna from Polydea. I'm a recruiter here, and I would like to invite on the stage Maciek Oczko, who is CTO of Polydea. Give it up for Maciek.
Okay, I didn't expect this, sorry. Yeah, I'm Maciej, I'm the CTO here, and I'm extremely glad that I see you here all, and I really feel very proud that we can co-host this meetup here, the very first meetup in Polydea about Airflow. And I would like to, thank a lot to Google Cloud for their trust and making this possible, and to our speakers, of course, for taking their time to share some insights about Airflow tonight. 2 words about Polydea, because some of you know us, some of you don't, I guess. So we are a design and development studio, and we are super excited about cloud and open source. We are actively contributing to Apache Airflow. That's an obvious thing, I guess, but also to Apache Beam. We are so engaged that we have a few of our developers that are actually Apache committers, and this is super awesome. And we love to be up to date all the time. So hence the idea to co-host this meetup and to learn something new from this Airflow world, which is absolutely exciting. 2 more things. I'd like to say that there will be a short quiz after the presentations, so stay focused and you can be rewarded. And I would like to remind you once again about the feedback service. please fill them. It will help us improve and making such meetups even better in the future. So I can't wait to see the presentation. So without further ado, I'd like to give the stage to the speakers. Thanks.
Wait, get me the notes. Thank you. Yeah. Okay. Hi everyone, and welcome to the first Airflow meetup in Warsaw. In this first talk, I will be introducing Airflow to someone who has never heard about it before. And I know that in the audience we have a lot of Airflow experts, so I will ask them to please bear with me. This is for the very beginners of Airflow. And the upcoming talks will dive into more details regarding Airflow. So, hi, my name is Victoria Nemkin. I'm a software engineer at Google for 4 months now in the data analytics team on the Cloud Composer product, which is essentially hosted Airflow on Google Cloud. I'm very new to Airflow, so I'm still learning. I'm originally from Budapest, Hungary, and I moved to Warsaw, Poland recently to work for Google. I have recently graduated from university. I was a demonstrator there, and I also did some competitive programming. And in my free time, I like to play video games, Minecraft, Terraria, and I used to play World of Warcraft, but I just don't have the time for it now. So, and that's about me. And let's begin the talk. So, what is Apache Airflow? Apache Airflow is a platform to programmatically author, schedule, and monitor your workflows. And why is Apache Airflow so great? Well, first of all, it uses pure Python. So there is no command line or XML black magic happening. You can leverage the programming language to run very flexible workflows. It has a very easy to use and beginner-friendly web application where you can interact with all of the Airflow components. It has plenty of integrations developed by the community. So chances are if you're looking for something, it has already been developed. It is very easy to use. If you know how to program in Python, which is also very easy to learn, then you can create all of your workflows in it. And it is open source, so you can see all of the code that is in Apache Airflow. You can contribute to it, and also you can benefit from the community around all of it. Yeah, so one of the first things that you will hear when people are talking about Airflow is DAGs. So what are these DAGs? They are directed acyclic graphs. And here's an example. It basically consists of nodes, A, B, C to G. And these nodes have edges running between them. And the directed part means that the edges are pointing from one node to another. In Airflow's case, the nodes represent all of the tasks that have to be running in your workflows. And the edges between the tasks represent the relationships between them. So for example, there is an edge pointing from task A to task B. It means that task A has to be completed before task B can be started. And the acyclicity. So acyclicity means that there can be no loops in the DAGs. And here's an example. You can see that task A, in order to start working on task A, you already have to have task H finished. But in order for you to start working on task H, you already have to have task G finished. And if you complete the loop, you will end up concluding that in order to start working on task A, you first have to have task A finished, which is impossible to schedule. So this is why we say that these workflows have to be acyclic. Okay, so let's talk about operators. An operator represents a single and ideally idempotent task. There's a bunch of operators present in Airflow. A few examples might be bash operator, which is used for running bash scripts, Python operator, which can be used for running your Python code, email operator, which can be used to send emails, and so on and so forth. And if you remember from the previous slide, we can say that, for example, task A is a Python operator, and it will run some sort of Python code that you have written. There are lots of integrations already. So here's a list of the integrations I have found. So chances are, if you want to write something, if you want to connect to a service, you will, or there is already an operator for it. But if it doesn't exist yet, then you can either use bash operator or Python operator and basically accomplish the same thing, or what is even better is to write your own operator and contribute it back to the community. Because if you need that operator, then probably someone else also needs it. And if the service that you want to connect to has an API, then it is very easy to write an operator for it. Okay, so let's talk a little bit about Airflow's architecture. There are three main parts in Airflow: the scheduler, the workers, and the web server. So the scheduler takes all of the DAG files, it parses them, and it is trying to find the tasks in these DAG files that have all of their dependencies met, and they are up for schedule. And if it finds one, then it gives it to one of the worker nodes that can start working on it. There can be as many worker nodes as you like, and they can be put on your servers, your VMs, your clusters. You can leverage all of your hardware that you already have to run your Airflow tasks. And the web server is what you can use to interact with all of these Airflow components, and let's look at it a bit more in detail. So when you load up a web server, this is the first thing that you're going to see. You will see a list of all of your DAGs in the DAG folder. And here you can see some basic information about them. For example, their schedules. It will be, for example, run daily or weekly or just once. And you will also see information about the recent task runs, when was it last run, and things like that. If you click on one of the DAGs, there will be a lot of views associated with that DAG. For example, the graph view, which is basically this DAG representation that we have talked about before. Another interesting one, for me at least, is the Gantt diagram, which will list all of your tasks in that DAG, and you can see when that task was run, how long did it take to run it, and also the timing information between all of the tasks. And there are a lot of more views that we don't really have time for all of that. And also, for example, you can see all of your web server logs here about the execution. And the thing is that this web server has lots of features, and I encourage you to actually install it and look at it for yourself and explore everything that it has. Okay, so now that we know a little bit about Airflow, let's look at some use cases, so how you can use Airflow for your tasks. This is a simpler one. So basically, I want to write an application that will look at RSS feeds on a website and send me the news updates to my email address. And the thing is that there are already websites doing this, but the problem is that they usually send advertisements along with the emails, and I don't really want to do that. So let's write my own application for it. So the first thing that I want to do is I want to read the RSS feed from a URL and download it to my machine. And for that, I can use a simple HTTP operator to get the results. This RSS feed is in XML format, so I want to parse this. For this, I can use some sort of Python module, and I can extract all of the articles from it. And now that I have all of the articles, I can use email operator to send the news to my email address. So if you're looking at this, you might ask, okay, but why am I using Airflow for this? I could just write a Python script and run it using cron. And for that, we have a more advanced use case. So let's imagine that you live in a small city and you work for the police station there, and they have lots of problems with bad traffic jams, and the problem is that the traffic light schedule is bad. So they have asked you to fix this problem. And of course, you are going to use machine learning to do that. So let's imagine that you already have a neural network, and it's already trained and it's awesome, and you want to periodically update the traffic light schedule, for example, daily, based on the current state of the traffic. So you have installed cameras in all of the intersections in the city, and you're going to use the images to predict, basically, the traffic and adjust the traffic light schedule based on that. So the first thing that you want to do is download the images from the cameras. And for that, you can use SFTP operator. And when you have the images downloaded, you realize that these are very big because the cameras make a very big picture, and you don't really have the space to store all of these images. So you want to scale them down. And also, neural networks usually like to work on a smaller scale image. They actually work better that way. And while you are there, you might also want to enhance the colors, use some sort of bash programs to accomplish that. And for that, you can use the bash operator. Okay, and now you want to save the metadata of the image, for example, the size of the image, the date it was taken, the intersection location that it was taken in, and save all of this data into a database using the SQLite operator. In the meantime, you realize that the images have some sensitive data in it, the car license plates, which you don't really want to store. So you find a Python module that can block out this information, and you can run this module using the Python operator to do so. And now that you have completely processed your images, you want to store them in a server. So you use another SFTP operator to do that. And after all of this pre-processing is complete, it is time to run your TensorFlow workflow to predict, to run it in prediction and update the traffic light schedule. And TensorFlow is in Python, so you can run it using a Python operator. And when you're complete and you have the new schedule for the traffic lights, you want the schedule to be approved by a human being before just pushing it to all of the lights, actually. So first you upload this to a staging database where a human can look at it. And to do that, you're going to use the SQLite operator. And then you are going to communicate with some sort of internal website the police has, that there is a new proposal, and it is waiting for human approval. And for that, you can use the simple HTTP operator to run a REST to connect to REST API. In the meantime, you also want to update your team, what you have done, and the super new schedule that you have. So you can use the Slack API post operator to send a message to a Slack channel about it. And also, maybe there is a police spokesperson that needs to be updated on the new light schedule changes. So you send an email to them using the email operator. And if you look at it now, this workflow is very complex. And the great thing about Airflow is that you don't have to worry about orchestrating all of this. What you have to do is just write every single task on its own and define the connections between them. And Airflow will take care of the rest. So this is where you can see the power of Airflow. OK, and since I'm a Google employee, I'm probably going to get the question, OK, but should I use Composer? And the answer to that is not necessarily. So Composer's users are typically enterprises. And we provide lots of additional features on top of Airflow. And using the cloud is also great because you don't have to worry about maintaining your machines. So, and in the next presentation, Leah will actually cover Composer and dive into all of the good stuff that Composer has to offer. But if you are just a developer and you just want to try Airflow out, then I encourage you that you install it on your own PC and play with it. And that was it. And thank you very much for listening.
Okay, so do you have any questions to Victoria? Okay, so maybe later during networking. Thank you very much. And now I would like to welcome Leah on stage. So the stage is yours.
Is my microphone good? This one? I'm going to wait to find out. While that's being worked on, I also want to introduce Julie from Warsaw. We're here.
We are actually working on Cloud Composer as well, and actually, Rafa, you want to introduce yourself?
Yeah, my name is Apache Airflow. I'm engineering manager responsible for the team that develops here in Warsaw Composer, which is a managed version of Airflow.
Okay. And I'm the product manager for Cloud Composer, so basically the managed version of Airflow running in the Google Cloud. So I just wanted to share one single fact here with you, which is that the strategy for Composer, which is a managed Airflow, as well as all the improvements, this is all being worked here in Warsaw, 800 meters away from here. So with this, with our contribution, with what Polida is doing, also to contribute to the Airflow itself, open source, and with all of you in the room here, we have a super strong foundation to create a strong community for all the Airflow users. So I'm really looking forward to all the energy and things that can come from this meeting, as well as many others. I also hope it's not just this meetup, but everything else we can do outside of meetups. And again, looking forward to all the collaboration here. So enjoy the evening and...
Besides us and Leah and Victoria, we have also Robert, who is a software engineer working on Composer. We have our colleagues from UX team, and they are responsible for making sure that Composer is friendly to all the users. So please talk to us after all the presentation.
Or feel free to reach out as well. We're sharing our email address quite openly.
And I'll share these slides after, so if you don't have the emails memorized, that's fine.
Thank you.
All right. Thank you, Philip and Rafael. All right, we are going to talk about Composer and Airflow. But first, I thought I would introduce myself. I am Leah. I am a developer programs engineer, usually abbreviated DPE, and at Google, but I am based in Sunnyvale, California, which is really close to Mountain View. Developer programs engineer is a fancy mouthful of words that really means that I am a software engineer, but instead of building core cloud products and tools, I build tools and experiences to make them easier to consume. That can mean things like tutorials, code labs, guides, talks that I give at meetups. And I specifically work with Cloud Composer, and that's this blue hexagon in case you were curious about those stickers. Outside of work, I like to crochet and knit. I will be doing that during the other talks, so if you see me holding yarn, that's why. And I'm a sometimes casual Airflow contributor. My contributions so far have had to do with docs and error messages. So why should or should you not listen to me? Well, I hope that those reasons, including the crocheting, are why you would want to listen to me. But I want to give some caveats. I am not a core builder of Composer. That is Rafael and Philip and Victoria and that whole team. But I do work with them very closely. And I am also not an expert. I have been at Google for about a year, and before then, I had never touched Airflow. And I don't use Airflow outside of work. So there may be some of you who do. And if you're looking for expert things from me, I encourage you to talk to each other as well. So my goals for you today. I hope that you will walk away understanding the differences between Composer and Airflow, learning a few best practices for using both, and meeting other people in this room who either use Airflow, Composer, or both, and also eat pizza. I'm going to go through a quick overview of Airflow, but not really because Victoria did most of that. I'm going to do an overview of Composer, do a little comparison, give you some best practices, and tell you what you should do when things go wrong. Not that you would ever get anything wrong, but just in case. So Victoria already did everything to tell you about the beginner concepts of Airflow. We have our DAGs. They are
acyclic. They schedule and are executed. And the one difference, or the one expansion I want to highlight is that generally we say there are three kinds of operators. There's an action which does something, like starts a streaming job. There are ones that are transfers, which move data from one place to another, and ones that are sensors, which is that they're waiting for some condition to be true. So now, Composer. Composer is managed Airflow on GCP. Victoria highlighted all of these things we know and love about Airflow. It's open source, lots of Python, flexible scheduling, tons of integrations, community support. Some things that aren't as good. Raise your hand if you've ever had trouble setting up an Airflow environment. Ever? Nobody? I think you're all a bunch of liars. With the exception of the new Breeze development environment, I would say that setting up a production level instance of Airflow is not easy if you're a beginner. And while there is logging and debugging, it's still getting some love and being improved. So where Composer comes in is it benefits from all the awesome things about Airflow, and it adds a little bit more to make it a more, I don't know, better might be the wrong word, but it has some features that are better for some enterprise users. It eliminates the overhead of the installation and the configuring and scaling and updating, so customers can really just focus on their workflows. It also has the addition of a few security capabilities. We use the GCP Cloud IAP product, which is Identity Aware Proxy, to protect the web server, so every request that goes to the web server is authenticated. And there's also the option to add shared VPC, that's Virtual Private Cloud, or private IP to your environment, though those are not required. Oh, I get some cool music.
It's a Mexican restaurant and someone.
That's awesome. Happy birthday. Cool. Anyways, I'm just going to talk louder than that. So it also adds operability and maintenance capabilities that are great. They have to do with Python dependency management, some propagation of Airflow configs, and in-place version upgrades, which is great. Some trade-offs, though, that you should consider is given that Composer is a managed service, you have less control. Someone is managing it for you. For some people, that is great. We have had customers who have run their own Airflow on GCP, and at that point are like, no, I want adult supervision, please take care of this for me. But others, that is not something they want to give up. It can be a little bit harder to run custom packages in your Composer environment. It's not impossible, but this is an instance if you're wanting to use some kind of Python package that's not on the public PyPy repository, then you have to do a little bit of workaround. And then the last thing is that sometimes the latest version of Airflow isn't in Composer yet. And given that Composer is a product that is in GCP, there are certain stability and security requirements we have to adhere to, which is why they're not immediately available. So this is a look at the actual Composer architecture diagram. I know it's a lot, but since Victoria had that beautiful one where she talked about the scheduler, the workers, and the web server, I wanted to bring it in the context of Composer. So if you look in this greenish box, the really small print says Kubernetes engine. So that's over here. And in there, that's where the Airflow workers live and the scheduler, among other things. If you look below it, the DAGs and logs and some plugins live in cloud storage. That's our blob storage offering. The logs live in Stackdriver, which is our logging and monitoring service. And then this purple box at the top says tenant project. If you're unfamiliar with GCP, project is like a notion of organization that we have. So the tenant project is just a bit more abstracted from what you interact with on the daily. It's the more managed part of this managed service. And that's where we have the metadata database, which is Cloud SQL is what our service is called, and that's a MySQL backend. That's where we have the web server, which runs an App Engine Flex, one of our compute products, and that's that identity-aware proxy that we're talking about. There's also some more GCP products under the hood, but this is your general overview. And this diagram is available in the Composer docs publicly. So now, before, yeah? Yes.
About the Kubernetes cluster, is it managed by GKE or is
yes.
it completely sealed off?
GKE. No, you can see your clusters. And you can run like kubectl commands on them if you need to, and you can see if nodes are giving you problems, if pods are unschedulable. Great question. I do it all the time. And I don't have special powers. So before I tell you best practices, I want to have 2 big points first. Everything I say to you, it totally depends. This might not be true for you because only you know what is best for your use case in your organization. So I can give you tips and tricks, but you need to think about them in the context of your work. So, environment configuration. The question that I get most often is, should you have one big composer environment or many small ones? Again, it depends. So let's talk about some of the advantages. If there's one big environment, the big advantage is it's one thing that you have to deal with. It's one thing of production support. It's one thing of billing. And it can be okay if you size your environment appropriately. Production support. So disadvantages. If you have a lot of people working on it on teams that are very disjointed and that perhaps shouldn't see what each other do, you might run into role-based access control problems. Airflow has limited role-based access control, but sometimes you run into teams have DAGs that you don't want other teams seeing, and it may be more trouble than it's worth to try to separate them from each other instead of just having them have their own environments. You can also run into problems with PyPy package conflicts. If team number 1 wants to use one version of a package and team number 2 wants to use another package, we all know that PyPy version package conflicts can be a real headache. So that's another case where you might want 2 environments or more. And the third is considering composer security features. We have that identity-aware proxy is everywhere, but if you are using the shared VPC, the private IP, and one team wants it and the other team doesn't, that's when you should probably have more than one. All right, so when you're making an environment, you also have to make some choices about the nodes that are running in that GKE cluster we were talking about. There are 3 main parameters you make decisions about. The first one is the node count. And the good news about the node count is that this is the one where you can make a mistake pretty easily. You can change it later. So it's okay if you're like, yeah, 3 sounds good, and later 3 is not good. So the default is 3. You can have many more. It all depends on how many tasks you have running. The second thing that you need to think about is the machine type. This cannot be changed later unless you choose to make a new environment and manually migrate yourself over to the new one. So if you're willing to do that work, that's fine, but you just can't change it in the same environment. This depends on how many DAGs you're running. You really have to think about that, and this is going to be relevant to your use case. But one thing to consider is that if you are doing something really compute intensive on a worker, consider changing that job to like spin up its own container, spin up its own VM, and that may help you if you're overusing your machine's capabilities. And the third thing is the disk size. This also cannot be changed later, and it's also a big depends on what you're doing. Some other things to think about when you're configuring your environment are parse time DAG dependencies. You want to make sure that, again, you're not doing heavyweight computation at parse time. The worker and scheduler nodes run on nodes whose machine types can be customized and can be made to have greater CPU, but the web server, which is in that tenant project, does not. That's a fixed machine type, and so that can lead to DAG time parsing problems and the web server being really unhappy if your computation is very heavyweight. One anecdote I have, a customer that I talked to, a very big customer running 1,500 DAGs in their environment, one single of their DAGs, it was just one that was the problem, had a very expensive select SQL statement in it that ran at parse time, and that basically made their whole environment unusable because of how much memory it consumed. Once we fixed that to be a less expensive statement, it was totally fine. You should think about the DAG size versus the number of DAG files. If you have a large DAG, you can run into DAG bag import timeout problems. If you have many DAG files, you can run into scheduling problems. So the best thing that you should do is try to balance the DAG size versus the number of DAG files. So for example, it is a better idea to have 20 DAG files, each of which have 100 DAGs in them, than to have 2,000 DAG files, each of which only has 1 in it. And again, that kind of depends on your organization. You'll figure out what that perfect ratio is. But In general, you want to be careful the more you have. A note, though, is that DAG serialization is coming in and is starting to help with some of this the web server health. DAG serialization, I think some parts of it are available. I know it's going to be more of a thing in Airflow 2.0. Some parts of it are already in Composer. For more details, I would ask the room to find someone who knows more about the serialization than I do. But stay tuned, that's a key word if you're having problems with big DAGs, many DAGs, and the web server, something that may help. I now want to talk about migration. And when I say migration, I mean both going from Airflow to Composer and from one version of Composer to another. So when going from Airflow to Composer, some things you may want to consider. We have blocked some of the Airflow configurations, and they're very publicly available on our docs. So if you look at one of those configurations and that's something you want to change, if you want to use Composer, either it's a no-go or you'll have to reconsider how you're doing it. You should note what Airflow versions are available. I said earlier, it's not always the latest version of Airflow. So if you really need something from a new version right now, might not be the best, but it might be anyways. And then you should learn about where the data is stored. Things like your DAGs and your logs. They're structured in a very specific way in Google Cloud Storage, so get educated. And when you create your environment, use Python 3. We still have the option to use Python 2, but don't. 2020's coming. You can do it. I believe in you. It is October. 2020 is very soon. Don't mess with the database schema. That's always good advice. And use Stackdriver monitoring. That's our monitoring and logging. I believe customers do have the option to turn it off. Don't. It's going to really help to have it on. So if you have one Composer environment and you want to upgrade it to another, this used to actually be a lot harder. You used to have to upgrade yourself, but it is available in place. It's a beta feature, but beta features are available to everyone. If you're not seeing it, you should look at the top right and check Enable Beta Features, and then you should be able to see it. What happens when you do that in-place upgrade is it redeploys the scheduler and workers in a new Kubernetes namespace, and then it creates a new MySQL database, but it preserves that DAG run history, and the database is named after the namespace. So if you've been interacting with things directly, you may have to change what name you use, but other than that, it'll just be in the new version. And the one limitation, two limitations, I lied. You cannot downgrade. So if you upgraded to a newer version and you're like, oh, that's a bad idea, you are stuck in your new version. And you can only upgrade within the same major Composer version. But the good news is that there is only one major Composer version that this is even available on right now. So you're totally fine. All right, I also want to do a little bit of a best practice for operators, but it's not going to be a deep dive because I know we have talks that go more into operators later. And it's just to reiterate what Victoria said. Before you define a complex task that integrates with some kind of external service, do some homework and see if an operator for that is already available. Recycle someone else's work. This is just always good programming advice in general. If someone else did it, see if you can use it. And if not, make an operator and give it back to the community because almost always someone else wants to do what you're going to do. And if you do that, it's a great source for like a talk to give at a meetup or a conference. Looks wonderful on your resume. So some general best practices. This applies not just for Airflow, but in life, but is very relevant, I think, when you're working in Airflow and Composer. You should document everything that you're doing and communicate it to your team. Did you make a very specific choice about how many nodes you did in your node count, or that machine type, or the disk size? Write that down, because if you're not on your team forever, the future person is going to be like, why did they choose that machine? We don't need that much power, but maybe you will in the future. Let the future you or the future other people know why you did what you did. Also write down what you've done for troubleshooting and either share it internally or externally if you're able to do that. It will save future you and future everyone so much time. And please contribute to the community. It doesn't have to be contributing code. You don't have to come up with a new amazing feature in Airflow. You can try to fix an existing issue. There are plenty open issues on Jira, and they are all triaged and marked and categorized very nicely. You can contribute to the docs. The docs always need love and are very helpful. You can answer questions on Stack Overflow or in another forum, and you can stay in touch with the people you meet here tonight. I would love to hear that someone has answered someone else's question. That would be amazing. So what about if you maybe messed up something in Airflow or Composer. What should you do when things go wrong? If you're not already on it, you should be on the Airflow mailing list. There is an Airflow Slack, which has a troubleshooting channel, as well as other targeted channels. There are docs. There is a wiki in Confluence. And then on Stack Overflow, these are the 4 Airflow tags that you can pay attention to. Or if you're not looking for help, but you want to answer, these are a way to refine your Stack Overflow so that you're answering only Airflow things. On the Composer side, we do have a public Google group called Cloud Composer Discuss. I lurk there, I sometimes answer there, and there's always people lurking and answering there. There are the docs, and then special note that there is support. If you have a managed service, that's one of the things you're paying for, is the ability to open a ticket up with a human who can help you, and that's pretty sweet. Stack Overflow also has its very own Google Cloud Composer tag, and also your new Meetup connections. Again, talk to each other. You're meeting a bunch of people who are all interested in or using the same thing as you. That's amazing and does not happen every day. So I'm going to wrap it up now because we have more speakers. The best way to reach me is probably Twitter, and I will have these slides public probably tomorrow or Monday, if not, and I'll make sure that the link to them is published in the Meetup group. So that's the best place to check. So thank you. Thank you for having me. And if you have any questions for me or Rafael or Philip, now is the time. And I don't know if Philip's going to be staying super late, so yeah.
I've got a question because as a backend database, you've chosen the MySQL.
Oh, good question. Is it why? All right, Philip, this one's for you.
So actually, I was not around when this decision was made.
Oh, that was going to be my line.
Already going hot potato.
So we are considering switching to PostgreSQL.
Yeah.
So,
Yep.
We're not going to SQLite though.
it was more related to Google Cloud Platform, not anything else.
Yeah, I think whatever the GCP offerings or capabilities were at the time, that was part of the limitation.
The major design of the proposal happened something like 1.5 or 2 years
Almost 2
ago.
years ago, yeah.
That's why this was the choice that was made at that point in time. The good thing is that we are flexible and we want to change it.
So I've got another question. When you have a Kubernetes cluster, because you said that when you're creating a new nodes for the Kubernetes, you can change the node type and the storage disks. But if you say that you can use kubectl to manage this, so I assume you have a Kubernetes cluster in GCP or GKE, wherever. If it's possible to use that directly, can I just add my own node pools for that?
Yes.
You can. So basically, the GKE cluster is directly in the customer project, so you can interact with it as with any other GKE cluster.
Okay.
So yes, but obviously, please know that if you mess up with it too much, your composer can break.
Yeah.
So why can't you scale up the disk or the resources?
Can you repeat the questions because the people who watch it do not hear the questions?
Oh, so the question is, why can you not change the machine type or the disk size? Why are those fixed?
So could it be like in-place migration, right? Or something
Right,
like
so at this point we do in-place upgrades, so you can upgrade between different versions of Composer, which also may include Airflow and stuff. But we don't really have a capability today, and this may come to change also the setup itself. To be honest, it's all a matter of what customers really demand and what is important for them. So if we have enough votes that this is really important, we can definitely consider such things.
One more. Is it possible to use the auto-scaling features in GKE for that?
Not at this point, no.
The question was, is it possible to use auto-scaling features?
So actually you should not even scale GKE itself. You should use Composer API to do the scaling and basically add more nodes through that. But at this point, GKE auto-scaling is not implemented in Composer itself.
Not the main thing is related to Celery framework, but basically the framework doesn't support auto-scaling feature.
Yeah.
This is actually the main reason why we don't support auto-scaling right now.
But we agree that's a great idea.
Any others? All right, you know how Thank you. Helping me out.
Where is the big mic? Can I have this microphone?
Masz?
Okay, thank you very much, Leah. Now I would like to introduce. Are you listening? Do you hear me? Okay, thanks. Okay, now I would like to introduce our colleague from Polidia, Tomek Urbaszek.
Hey guys. And as Justina said, I'm working in Polydia and I'm contributing to Airflow on daily basis. And I would like to talk today about our journey with creating, in fact, operators for the Airflow. And to give you some context, I think it doesn't work. Oh, yeah. In Polydia, we have already created more than 80 operators, mostly for GCP services and Google services, in fact. And I think that if you ever create an operator once, I think you can be bored. It's mostly doing the same thing over and over again. So the question is, so how we did use to develop Airflow operators in past? In the past, we approached this in a really boring way. We just copied an already existing operator. We just fixed its code to change the logic to serve the new service. We adjusted comments and doc strings. And I think there were some operators that even hinted where was the original code, like there was a typos and things like that. And finally, you write tests. And there are a lot of cons of that approach. It's tedious, it's boring, it's error prone, as I said. If there is a typo in the operator you are copying, you are going to copy this over again. And it's not very creative. So, is there any pros? Yeah, it's a good approach if you want to create your first operator. If you want to start with something already existing, it's a good approach. But I think it would be best if you start with scratch, just write your own class. So the question is there any better approach? Well, to answer to this question, we have to understand what is common for some operators, what can we automate and what cannot be. So what all operators have in common? Well, that's obvious. There is a class definition. Operator is a class. So we have a part of code that could be copied and copied over. There is a class docstring, which is under the definition of class. There is constructor, which in most cases just takes some arguments and assign them to operator attributes. And next, there is execute method that just takes one argument, its context, and performs some action that also could be somehow seen as something common between operators. But there are also differences. Every time when you create an operator, you have to assert idempotency. That means that if you are going to create a new resource like data pro cluster, you have to check if this cluster already exists. Because if it exists, you should reuse it. So if there is something, you want to reuse it, not create the same thing over and over again. Next, you have to deal with some error handling. You have to understand the service you are going to integrate with. And some operators needs waiting for a result, like you submit some request and you have to wait a few seconds or even few minutes. The longest time I was waiting was like 1 hour, 40 minutes for AutoML operators to create a model. And you should do logging. A meaningful logging is really good thing in operators because it helps to debug them. And I think we can agree that the interesting part are the differences between operators. And the boring one is something that can be automated. And the question is, how can we do this? How can we automate boring thing? And I will tell how we approach this when we started to think about generating GCP operators and Google services. So first of all, we have to ask ourselves, what resources do we have? From what places can we take information about the service we want to integrate with? So in case of Google, there are 2 places. It's Google Discovery API, which is available for all Google services, and also Google Python libraries. So if there is a Python library, then we prefer to use it instead of Discovery because there is a lot of things that are already implemented. And we also took some assumptions. First of all, we decide that each service should have a dedicated hook. So if you are going to integrate with YouTube, for example, you should create YouTube hook. And the hook should be a thin layer between the operators and the API you are going to integrate. And what the thin layer means. And for example, if we have a client which have, this is some Python library like AutoML or Dataproc client, whatever. And it has create model method which needs 2 arguments like model and parent. Then we want to user to not provide the parent, which in fact is some kind of URI. It's just a concatenation of few strings. We want use already existing methods from the client, which is location path that returns the parent, if we provide 2 additional arguments like project ID and location. So in fact, we are creating a create model method for the hook, which implements really thin layer. But in this way, we are making the hook more user-friendly and easier to understand. Just pass 3 arguments, model, location, and project ID, and everything will work. And the last assumption is 1 method, 1 operation, 1 operator. We don't want operators to be like, set the mode of the operator. No, we don't want such things. So if you want to create something, you have 1 operator. If you want to list some resources, you have another operator. So, how you approach the generation of the operators? First of all, you have to find out what source of information you are going to use. So you can, first you check if there is a Python client. You can check this on Google Cloud Python GitHub repository. If there is no Python client, then you use Google API Explorer to check what is the name of the service you are going to integrate. Next, you want to parse all available information. You want to know what is available at the service. What are the available methods? What arguments they need? What are the types of those arguments? What are the default values? And what is, for me, in fact, is the most important is description. Because if I can get a description what the operator will do, I don't have to copy, paste this from website or any place like that. So when I have this information in some form like abstract syntax tree or anything else, I can generate as much code as possible. In fact, I want to generate as much code as possible. I want to generate code for the hook, for the operators. I want to generate unit tests. In fact, I can generate unit tests. I want to create simple system tests that will use example DAG. So I will generate example DAG that needs only little tweaks to be working. And finally, I create how-to-guide template that could be filled easily. And why do how-to-guide? Because when we are contributing operators to Airflow, we always want leave information how you should use the operators, because it's not always obvious how the service works. So, for example, let's say that we want to create operators for dataprog cluster control client. That's some Python class that implements create cluster, update cluster, and delete cluster methods. What I want to do is I want to parse this information, the Python code, and create something that will be dataprog hook and will have the same methods with the same doc strings, same arguments, same times, same default values, but will implement a thin layer that will make using hook much more easier. And finally, when I have a hook, I can create dataprog operators. And as you can see, what we are doing, we try to, if we have a Python client, we want to keep the names of the operators, of the methods in the hook, as much similar as it's possible. So we have create cluster, create cluster operator. And for example, this is a dataprog hook which was generated by our tool. And you can see, well, there's no doc strings. This could be fixed. But we have getCon method that is, has a quite nice description. And we have initialized cluster control client with credential that are provided by Google Cloud-based hook. And here is the create cluster method that was automatically generated from the original method. As you can see, we have arguments, we have types, default values, we have awesome docstring, which was reformatted to the format of the Airflow. And we are retrieving the client, and then we call the create cluster method of this client, and we return a result. This is something that you, in fact, get for free. Whatever else you want to do with this, it's up to you. But this is generated in 20 seconds. And so we have a create cluster method, and we want to use it in dataprog create cluster operator. I removed the doc strings because it was large. And same here. We have arguments, types, default values. We assign them to attributes of the operator. And finally, we have execute methods that initialize the hook and create the cluster. So this is the part you have to, in case of, for example, create cluster, you should do some idempotent assertion here, like check if the cluster already exists. If yes, then return the cluster. If not, create new, etc., etc. But what I want to point out is this point where we initialize the hook in execute. It's really important to initialize hooks or anything else that query database or may query database in execute. Because otherwise, if you do this in operator, in the constructor, you are going to have a lot of queries. Every time your operator will be initiated, for example, in your DAX, when the web server is parsing your DAX or scheduler is parsing, there will be query to your database. So every time you refresh the web server, there will be query. That's not the best idea. Also, we have issue to remove these applied defaults from execute because it's only applied to it. So, okay, so how we deal with the discovery API? In this case, we are starting with one request, one GET request that returns us all information about the endpoint. We get all methods. These dictionaries, in fact, include all information we need. There is description, needed arguments, types, default values. So we do the same. We parse this. We create campaign manager hook in this case. We create, in this case, you can see that we are just tweaking the name. Like, we don't want to list. We want to list report. We want to say what we are going to do. And that's also done automatically. And we generate the operators. So here it is example of the campaign manager hook. You can see that in getCon we are building the discovery resource for the DFA reporting, which is endpoint for campaign manager. And for example, we have insert methods that accept profile ID body and builds the request for the insert report endpoint and execute it. As you can see, we are trying to leave something to do to developer. Like if there is something we knew that has to be changed, we are leaving to do, just developer can easily find what to do. And yeah, so we have campaign manager hook, and this could be reused in Google Campaign Manager insert report operator, that's long name. And here we have the short description from the endpoint. We have automatically generated types, parameters, types, and we have the init and execute, which initialize the hook and inserts the reports and returns this. Same as before, you should assert some idempotence if it's required. In this case, I think it's not. So, short summary. First of all, learn to automate boring stuff. Really, if you are going to develop 100 operators, then you are starting to think what can be done more creatively with a lot of fun. The approach we used can be extended to any API, to any library. Especially if you write a parser for some type of docstrings, you will be probably able to reuse the parser for many libraries, because the docstrings there are just a few types of docstrings. So you have free parsers, you have a lot of libraries to automatically generate. And feel free to use the generator to create new GCP operators. And if you use them and you have the operators, please make PR and contribute them back. We'll do everything to make a good code review and see them merge as fast as is possible. The generator is available at our internal repo, Airflow Munchkin. Munchkin is a code name for, well, it's a breed of a cat. Yeah, and that's all I have. One more thing, if you are interested in contributing to Airflow or in working in Polydia, here is Justina who will answer all your questions. So, thank you. And the questions?
I have a question. I wanted to know how often you run the generator to account for updates in the APIs and the client libraries. Does it get rerun on a schedule for existing ones?
No.
Could you repeat the question?
Yeah, the question was, if I fully understand, are we running the generator on already existing operators to update the code? Yes?
Yes, that was my question.
Yeah. So no, but it's a great idea. We are. Yeah. Yeah. I see the point. No, but for example, we are retrofitting the operators. So, for example, I was using this generator for dataprog, and it was like just 2 minutes of creating new operators, fully functional, and not playing with the old code, just making some tweaks to make backward compatibility. But it's really easy to use.
I also have a comment that Google auto-generates some of the client library stuff. So automating boring stuff is fantastic.
That was our inspiration, in fact. Yeah. So, any more questions? So, thank you.
Okay, thank you very much, Tomek. Now I would like to welcome Bartłomiej Bęczkowski from Allegro.
Okay, so first of all, I am really sorry for my voice. I lost it like a few hours before the talk, but I will do everything I can so you can hear me. My name is Bartek and I work at Allegro, where we use Airflow extensively. And Airflow in Allegro is used not only by engineers, but also, for example, by data analysts. And that's why I want to tell you a story about imaginary average data analysts that would like to create a report on GCP, probably using Data Studio. That will be refreshed every day, so business has the fresh data to make decisions. So it probably comes down to creating a series of queries and scheduling it somehow. So first of all, what are the tools on my disposal? I definitely know some SQL to write my query. I have my beloved Jupyter notebook that is like a puppy. No one hates puppies, no one hates Jupyter notebooks. I have a Python as a tool to explore my data, for example, by using matplotlib, pandas, and other libraries. And I can do pretty much anything that involves clicking. So I can use spreadsheets, I can use Data Studio and Tableau for visualization. So what is the obvious solution for that problem? It's just using Google BigQuery console for writing a query, testing it, and scheduling it, because Google BigQuery console allows you to schedule a single query. But problem is that it's okay if query is tiny. The problem occurs when it becomes unmanageable. So I need some other solution that will help me to split my code and schedule a series of queries, or maybe graph. So I go to my friend data engineer and ask for help. And I get a clear message that you should use Airflow because it has sexy UI and it can do pretty much anything you can imagine. So here you go. And I'm really happy with what I saw. So I go to my computer and I start reading documentation, Airflow documentation. And the first thing I realize is that Airflow is not some kind of software as a service. So I need to manage my own Airflow. And it's way, way beyond my technical skills. Fortunately, that problem is already solved by the Cloud Composer, which we also use extensively in Allegro. So that's a great tool, and that solves my first problem. The second problem is writing a DAG, testing a DAG, and in general, doing anything in Airflow if you are not an engineer. Why? Maybe because I don't even like using command line and I don't know how to use it. And I see so many new words that I don't understand, like operator, DAG, configuration, scheduler, etc., etc. But all I wanted to do is just to schedule few simple queries. So that's where the tool that we created in Allegro comes to the rescue. So first of all, what is the bigger query? I will switch to our GitHub repo. Give me a second. Okay, so I want to quit full screen. And as you can see, it's a super fresh product. We open sourced it recently, but we worked on our internal version of the bigger query like a long time ago. And what is the bigger query? So it's a framework that takes the opposite direction to the Airflow, because Airflow is a very generic tool. As I said, you can do pretty much anything that involves data processing pipelines in any technology you can imagine. So if you are working on GCP, that's okay. Airflow can handle that. If you are working on Hadoop, no problem. And in bigger query, we took the opposite approach, and we took very specific use case or problem, which is creating workflows using GCP technologies. So it is limited to GCP, but because of that, it's much easier to use. So if you want to contribute or even try it out because you work on GCP, then I encourage you to follow the bigger query tutorial, which is a bunch of Jupyter notebooks that you can run, for example, in Jupyter Lab in a few seconds. So now the trickiest part, which is live demo. So let me switch to the console. Okay. So as you can see, I already prepared my machine with a Jupyter notebook. And what I want to do, as I said in the beginning, I just want to schedule few queries. So I already prepared some queries that I want to schedule. And there is not much that I need to think about. So there is a Python code, some methods like write-on-kate, which just writes data to the table that I want. In this case, it's user transaction metrics, whatever it means. I want to work on the chosen data set, which is some transactions data set, and I will use user transactions metrics table and transactions table. So I can work with those queries inside the notebook. I can run them, pick the results, and do much more. Everything from the beloved Jupyter notebook. And when my workflow is ready, I wrap it up in a workflow object. And now the question is, how can I schedule that thing on Airflow? Well, there is a method that will generate that DAG for you. So you don't even have to know how DAGs works, what's inside. You can just generate the DAG, and I already did it here. Maybe I will do some changes to generate another DAG. So just that I will change the name of the DAG, save the notebook, and hit run. And I got another zipped DAG, which I can deploy on my Cloud Composer, which I also prepared earlier. By drag and dropping the zip to the DAX folder. I did that previously, so earlier, so now I can show you a ready DAG in my composer. So as you can see, it's working fine. I scheduled 2 queries, and they were translated into DAG automatically. So it's not just like taking the Jupyter notebook and scheduling the whole notebook. It's like it's able to split the logic. The framework is able to split the logic and translate it to the DAG. And what is important that it's super easy to start working with the bigger query, but it's not limited to such simple use cases. We use bigger query to power our experimentation platform, which is pretty important for us. And we start using it in another projects to spread it around the company, especially in teams that are without the support of the data engineer in a daily basis. So if there is a team that consists of data scientists, that framework will be extremely helpful for them. Because all they want to do is focus on the processing logic and not the tiny details that Airflow requires from you to know. Of course, if you need to configure more your processing, you can do that. And I think that someday it will be even more, there will be even more possibilities to extend the DAG made by bigger query. So that's all. Thank you for your attention, and I hope you have some questions.
Operators in the DAG or the look of the DAG.
Okay, so you are asking me if you can like change the DAG that we generated for you. To some extent, yes. So I think that the simplest way to show you what is going on inside is just take the DAG that I generated, and it's not here. Okay. Give me a second. Okay. Here is the DAG. I will download it. And I have no idea where Safari saves files. So I ask for help right now. But okay, so you can modify it to some extent. we avoid like generating code as much as possible. So it comes down in the current version to for loop that takes the configuration of the Python operators for each step and set up an operator for each step. So you can, for example, change the configuration of the whole DAG easily, but you might have a problem when you want to change a single operator.
You have a specific case for which you define DAG, and you have a tool that allows you to update the queries you do in the DAG, yes? So if you would like to create new use case, you have to create new template, new generator? No? No.
The bigger query is a framework that allows you to combine BigQuery, Apache Beam, and Python and create processing pipelines using those technologies. So with those tools, you can do anything you like. If you want to extend the bigger query, for example, if you want to use, I know, Spark, so Spark on cloud, you have to extend the bigger query. There's no other way. Okay. Here's the question. Okay, but for example, can I set up my own Apache Beam processing? Okay, so I definitely will check it out. Okay. Short answer, no.
You let the analyst deploy the DAG himself, herself, then how do you conclude tests on the DAG? And do you have like shared instance of Airflow or is it an instance per user?
That depends. If that is some really important processing that we should retest and like put into a real engineering process, then probably bigger query is not the right tool for you. It suits the situations when your processing is not critical because it meant to be a tool, self-service tool. For data analysts and data scientists in some use cases. And about the shared instance of an Airflow, cloud composers are spawned by each team separately, and we don't share cloud composers, but we share Airflow in our DCs. So we have, for example, a special Airflow for all the data analysts if they are not able to handle their own Airflow instance because they don't have the support of a data engineer in their team. Okay, so thank you very much.
Okay, I would like to invite the speakers one more time. Yeah, sure, log out. Because I would like to give you some gifts. So Victoria, Leah, and Tomek, come on stage one more time. By the way, okay, give it up one more time for our speakers. By the way, if you'd like to have same awesome gifts like this one, you have a chance right now, because what we are going to do is a little quiz. So do you know Kahoot? Do you know this? Okay, this is like a tool for a quiz. Give me 2 or 3 minutes. I just have to log in. This is a good time to refill your, yeah, bellies with pizza and beer. Bo to mi znikło chyba z tego. To mi znikło z tego ekranu. Okay, we are starting in like 1 minute, so... Nie, no bo... Bo to musi być... To musi być... Co? Nie, bo martwię się, że tego nic nie... No nie zrobiłam po prostu to i to mi włączyło full screen.
Can you remind them of the survey?
Yeah, okay, sure.
Thank you.
No problem. No bo to właśnie musi być... Co? No, da się to z powrotem... No chcę tak, żeby to było wszystko. Tak po prostu. Nie. Dobra. Okay, okay. Can I have your attention for this game? Yeah. Jarek. Okay, so you just have to wait. Oh no, it's not working. Shit. Okay. So join at kahoot.it and the game pin is 8713. We have a first player. Whoa, 7 players already. We are waiting for more players. Everyone can join. Yeah, sure. Okay. Are we waiting for someone else? Are you ready? Okay. It seems that you are ready. So, there will be 5 questions and 4 answers for each question. I will not read the answers I don't want to confuse you. I will read the question and the answers will be visible there. And not only the correctness counts, so the correct answer of course should be picked, but also the time. And you have 20 seconds for each question, but when you are sure, just pick the good answer. Okay? All clear? Let's start. Are you ready? What does the acronym DHD stand for? Three, 2, 1, go. Cool, good for you. 23 people knew the answer. Let's see who's winning now. JY, cool. Okay, so the next question is, what is the most beloved tool by an average data analyst? It's a tricky question. Yeah, I know that's a very difficult question. Ta-dam! Jupyter. Yo. Okay, 18 of you knew the answer. Let's see who's winning now. Piception. Congratulations. What is an airflow operator? And 3, 2, 1. 16 of you. It's getting more difficult. Maciej is winning. And fourth question. When did Google Cloud Storage launch? Last 3 seconds. Congrats. 2010. And the last question, my favorite one. Maciej Szy is still winning. Let's see who will win after all. It's the last question. What's the slogan of Polydia? I know. It's not on the roll-up, so it's difficult. One, go. It's, by the way, unique tech. So the green one was the correct answer. And so let's see the result and who won. Da-da-da-dam. Really? Okay, who is anonymous? You? Okay, so come on stage. Okay, guys and girls, thank you very much for the whole meetup. We'll still have some time, of course, for networking, eating, drinking. And the last thing we told you about this feed-based service, it's like 3 minutes, and it will really help us to get better, to do more meetups that will be even better or much better than this. Thank you very, very much.